Welcome to the video for 2.01 where we're going to look at the mole. So key points from today's lesson is that a mole of a substance contains 6.022 times 10 to the 23 particles, and that number is known as Avogadro's number. And what that particle is depends on what substance you're talking about. So unless you're talking about a diatomic element, then if it's an element, it's going to be Avogadro's number of atoms. If you've got a diatomic element, such as the group 7 element or hydrogen, nitrogen, or oxygen, then it's going to be that many molecules. If it's a simple covalent compound, then it's going to be that many molecules. If it's a ionic compound, then you don't have molecules, so it's going to be that many number of the formula unit. So if you've got a mole of an element, it's going to have the same mass as its relative atomic mass. So if you've got a mole of carbon, it's going to weigh 12 grams. If you've got a mole of fluorine, then because it's F2 and fluorine is 19 and 9, so it's going to be 2 times 19, so it's going to be 38. So a mole of fluorine would be 38 grams. So you have to watch out for whether it's diatomic or not. If you've got a mole of a compound, then it's going to have the same mass as its relative formula mass. So if I had a mole of water, that's going to be, sorry, my pen's just gone a bit dodgy. So if you've got a mole of water, that's going to have a formula mass of 2 times 1 plus 16, so it's going to be 18 grams. So if we are sometimes asked how to calculate the mass of one atom or one molecule. So if I wanted to calculate the mass of one molecule of water, so water, as we said on the previous slide, has a molar mass of 18 grams. So 1 mole is going to have a mass of 18 grams, and that's going to be Avogadro's number of molecules. So then we can use ratios. So if that many molecules has a mass of 18 grams, 1 molecule, so to get from 6.022 times 10 to the 23 to 1, I've divided by Avogadro's number. So whatever I've done to that side, I need to do to this side as well. So I divide that side by Avogadro's. So that will give me 18 divided by 6.022 times 10 to the 23 in grams. And if I stick that into my calculator, that's going to give me 2.99 times 10 to the minus 23 grams. So 1 molecule of water is going to have a mass of 2.99 times 10 to the minus 23 grams. So we also need to know this formula, so we can abbreviate that to number of moles is mass over mR. And we need to be able to rearrange this, so I can rearrange that to give mass is number of moles times by mR. And if I want to know the mR is going to be the mass divided by the number of moles. So if we don't like rearranging equations, then you just need to learn the magic triangles. So here's an example exam question. So it's asking us which contains the most molecules. So that's going to be the same as the number of moles. Okay, and it's easier to work out the number of moles because these are in grams. So I'm going to have to convert that to, sorry, not D, because that just gives you in moles. So B and C are in grams. So I can convert them to number of moles. I would then have to convert them to the number of molecules, but this one's already in molecules, so it's quicker to convert them all to moles. So for A, I know that 1 mole of methane is going to have 6.022 times 10 to 23 molecules. So 1 molecule is going to be, so to get from there to there, just like I did on the previous slide, I'm divided by Avogadro's number. So if I do the same to this side, sorry, my pen's disappeared again. If I do the same to this side, so I divide by Avogadro's number, that gives me 1 molecule is 1 over 6.022 times 10 to the 23 moles. But I've got 2.1 times 10 to the 22 molecules. So that's going to be 2.1 times 10 to the 22 over 6.022 times 10 to the 23. And that's going to tell me how many moles. So if I stick that into my calculator, that gives me I'm just going to find my calculator. So 2.1 times 10 to the 22 divided by 6.022 times 10 to the 23. So that's going to give me sorry, it's taking a while on my calculator. Right, so that gives me 0.0349 moles of methane. So for the oxygen, I just need to do number of moles is mass over MR. So that's going to be 1 over 32. And if I stick that into my calculator, that gives me 0.03125. If I do the same for this, so number of moles is mass, so that's 65, but it's in milligrams, so I need to divide that by 1,000 to get it in grams. And then the mass of this is 2, so if I stick that into my calculator, that gives me 0.0325 moles. And now if I look at all of these numbers, I can see that this one is the highest number, so that contains the most number of molecules. So a second question that we can look at is we've analysed a sample and we've got this formula here, and it shows that we've got 0.0195 moles of carbon. What mass of nitrogen? So if we look at this formula, 22 moles of carbon is going to be the same as 6 moles of nitrogen. So therefore, by ratio, 1 mole of carbon is going to be 6 over 22 moles of nitrogen. So if I've got 0.0195 moles of carbon, by ratio, I'm going to have 0.0195 times by 6 over 22 moles of nitrogen. And if I stick that into my calculator, I get 5.32 times 10 to the minus 3 moles. But now I need to use number of moles is mass over MR. And if I rearrange that, I get mass is number of moles times by MR. It's going to be 5.32 times by 10 to the minus 3 times by 14. If I stick that into my calculator, I get 0.074 grams, which is C. So our correct answer is C. Okay, thank you for listening. See you next time.